What happens if our sun suddenly became a solar mass black hole? Most people expect Earth would get sucked into a dark void immediately. The reality is far different. Based on 2025's Event Horizon Telescope imaging, we know black holes appear as bright rings of superheated gas surrounding a dark center. More importantly, if a black hole had the same mass as our sun, Earth's orbit would remain stable initially. No dramatic vacuum effect would occur. The latest orbital mechanics data reveals the true horror lies not in instant destruction, but in the gradual changes that would unfold over thousands of years. Combined with new gravitational wave observations and updated black hole imaging technology, we can now map exactly how this cosmic swap would transform our world. The process is simultaneously more subtle and more terrifying than anyone imagined, starting with what you'd actually see in the sky. The reality glitch effect. Looking directly at where our sun used to be, you'd witness something that defies every expectation about how space should behave. The 2025 Event Horizon Telescope data reveals that black holes don't appear as simple dark voids. Instead, gravitational lensing bends light from background stars in ways that create multiple distorted images of the same celestial objects. You wouldn't see a single star in its normal position. Light from stars behind the black hole gets redirected by the intense gravity, causing the same star to appear in several locations simultaneously. The Event Horizon Telescope's observations of M87's black hole show exactly this effect, single light sources creating multiple images stretched and warped into impossible shapes. Some stars would appear above the black hole below it, and beside it all at once. The visual information would contradict everything about how light normally travels through space. The photon sphere adds another layer of strangeness to what you'd observe. This region surrounds the black hole where light gets trapped in unstable circular orbits. Recent EHT images show how this creates a flickering photon ring effect around the black hole's silhouette. From Earth's perspective, the black hole's outline would shimmer and blur as trapped photons complete their orbital dance before either escaping or falling past the event horizon. One moment you'd see a clear dark boundary, the next it would distort as the photon ring brightens and dims. Time dilation near the event horizon creates additional visual chaos. According to Einstein's relativity, clocks closer to the black hole tick slower than those farther away. Objects at different distances from the black hole would appear to move at dramatically different speeds. A comet falling toward the event horizon might seem to crawl through space, while debris farther out moves at normal velocity. Your perception of motion would become completely unreliable, as different regions of space operate on different timescales. The colors would transform into something alien. Light gets redshifted and blueshifted as it interacts with the black hole's gravitational field. Stars that normally appear yellow might glow deep red or brilliant blue, depending on their position relative to the gravity well. You'd witness color combinations that don't exist in normal space, wavelengths shifted into ranges our eyes never evolved to interpret. The familiar constellations would become unrecognizable patterns painted in impossible hues. Navigation would become completely useless under these conditions. GPS satellites depend on precise timing and clear sightlines to reference points. With multiple images of the same stars appearing in different locations and time running at different speeds throughout the solar system, any navigation attempt would fail. Ships trying to plot courses would receive contradictory readings from their instruments. Pilots would see their destination in 3 different directions simultaneously, each image showing a different version of the same location. The 2025 gravitational wave detectors reveal that black holes produce measurable ripples in spacetime as they interact with nearby matter. These aren't sounds you could hear, but distortions in the fabric of space itself that instruments can detect and convert into audio signals. The black hole replacing our sun would generate a constant background hum, punctuated by sharper chirps whenever it consumed asteroids or comets. Space would literally sing a death song that only our most sensitive equipment could detect. This gravitational wave background represents space-time distortions rippling through the universe constantly. When galaxies collide and their central black holes merge, they spiral around each other before combining like cosmic symbols, generating waves that warp reality itself. Our replacement black hole would add its signature to this cosmic chorus, broadcasting the solar system's transformation across the galaxy through gravitational tremors. NASA's collaboration with ESA on the Laser Interferometer Space Antenna mission means we can detect these gravitational waves from black holes with masses reaching hundreds of millions of solar masses. The technology exists to monitor our own destruction. Other civilizations with similar equipment would detect the gravitational signature of our solar system's transformation long before any visual effects became apparent to them. Animals that navigate by celestial objects would find themselves completely disoriented. Birds migrating by star positions would fly in circles as they attempt to follow reference points that appear in multiple locations. Marine animals that use stellar positions for orientation would lose their reliable guides. The entire ecosystem would lose its navigational foundation as the sky became an unreliable map. Even scientific understanding would be challenged by these observations. The extreme gravitational fields would bend light in ways that create optical illusions impossible to reproduce on Earth. Researchers would struggle to distinguish between real phenomena and gravitational mirages. Measurements of distance and time would become unreliable as different observers in different locations experience reality at different rates. The psychological impact on humanity would be profound. Looking up at a sky where physics appears broken would force people to question fundamental assumptions about reality. Children growing up under such conditions would develop completely different intuitions about how space and time function. The concept of objective reality would lose meaning when everyone observes different versions of the same cosmic events. Weather patterns would become unpredictable as gravitational lensing focuses and defocuses radiation from distant stars. Some regions might receive concentrated beams of starlight, while others fall into shadow as light gets redirected around the black hole. Energy distribution across Earth's surface would follow no recognizable pattern, making climate prediction impossible. All this visual chaos and sensory distortion represents just the surface level of what humanity would face. The warped light, shifted colors, and fractured reality serve as warning signs that something fundamental has changed in our corner of the universe. But these spectacular effects would mask a more subtle and ultimately more dangerous process already beginning to unfold. The gradual orbital decay. Earth's orbital mechanics would remain completely unchanged. This fundamental truth about physics creates the most deceptive scenario imaginable. When our sun gets replaced by a black hole of equal mass, Newton's laws and Einstein's relativity both confirm that gravitational forces stay identical. The inverse square law means Earth experiences the exact same gravitational pull from the same distance. No dramatic sucking effect occurs. No instant death spiral begins. All the planets continue their normal orbits as if nothing happened. This initial stability would fool everyone into thinking humanity dodged the worst possible outcome. Scientists would measure Earth's orbital parameters and confirm we're maintaining our standard 93 million mile distance. The gravitational field strength remains exactly 9.8 meters per second squared at Earth's surface. Orbital velocity stays at 67,000 miles per hour. Every measurement would match the textbook values for a normal solar system, creating false confidence that the fundamental structure of our cosmic neighborhood survived intact. The psychological relief would be enormous but completely misplaced. Politicians would make speeches about humanity's resilience in the face of cosmic catastrophe. Engineers would focus on immediate survival problems like replacing solar energy and maintaining heating systems. Everyone would treat the orbital stability as proof that we could adapt to this new reality. The assumption would be that if we can solve the energy crisis, we might actually survive this transformation. but astronomical navigation would become impossible almost immediately. Star positions would multiply due to gravitational lensing around the black hole, making celestial referencing completely unreliable. Ships and aircraft that depend on stellar navigation would find themselves unable to determine accurate positions. The familiar constellations would appear in multiple locations simultaneously, each image distorted by the black hole's gravity well. Navigation systems that worked perfectly for thousands of years would become useless overnight. The orbital mechanics would begin changing in ways so subtle that detection would take decades. Earth's path around the black hole would start becoming slightly more elliptical with each complete revolution. These changes would measure in millimeters per orbit initially. The most sensitive instruments might detect tiny variations in orbital speed and distance, but the shifts would fall within normal measurement uncertainty ranges. Early warning systems would classify these anomalies as sensor errors or atmospheric interference. According to updated orbital mechanics calculations, this gradual spiral would unfold over thousands of years. The timeline would create a twisted form of hope that makes the situation infinitely worse than instant destruction. Thousands of years sounds manageable when you're dealing with immediate survival problems like freezing temperatures and agricultural collapse. Governments would classify orbital decay as a long-term concern for future generations to address. Scientists would publish research showing humanity has plenty of time to develop technological solutions. This would create the most psychologically devastating scenario in human history. Every generation would grow up knowing their planet follows a collision course with oblivion, but that collision remains centuries away. Your descendants might witness Earth's orbit becoming noticeably unstable, but you personally would die of old age long before conditions become critical. Each generation would inherit the same hopeless situation with slightly worse orbital parameters. The death countdown would become embedded in human culture. Children would learn about orbital decay alongside basic science concepts. Insurance companies would develop actuarial tables that factor in gradually increasing tidal disruption risks. Philosophers would debate the ethics of reproduction when you know descendants face inevitable doom. Dating applications would include planetary viability disclaimers. The slow timeline would make the threat feel abstract while remaining absolutely certain. Each orbit would bring Earth microscopically closer to the point of no return. The changes would require sophisticated equipment to measure, but would be completely relentless. Every 365 days, Earth would complete another revolution and end up fractionally closer to the black hole's event horizon. The orbital period would gradually decrease as gravitational acceleration increases. Years would shorten by fractions of seconds, creating a cosmic calendar that slowly accelerates toward disaster. Advanced civilizations would attempt to counteract orbital decay using theoretical propulsion systems. Engineers would propose massive rocket arrays positioned around Earth's equator, designed to nudge the planet back into stable orbit. The energy requirements would be staggering. Moving Earth requires generating thrust equivalent to accelerating 6 trillion kilograms of mass. Even covering the planet's entire surface with nuclear rockets would require fuel exceeding the mass of several moons. Alternative proposals might include gravitational assists from passing asteroids or comets, carefully timed to boost Earth's orbital velocity. Scientists would calculate launch windows decades in advance, planning cosmic billiard shots that use smaller objects' momentum to alter our trajectory. The precision required would make Mars landings look simple by comparison. One miscalculation could send Earth spinning into interstellar space or directly into the black hole. As thousands of years passed and orbital decay continued, tidal forces would finally become strong enough to affect Earth's rotation and geological activity. The black hole's gravity would pull harder on Earth's near side compared to the far side. This differential would create internal stresses manifesting as increased earthquake activity and volcanic eruptions. Earth's crust would get stretched and compressed during each orbit, generating friction heat that might partially offset lost solar energy. The planet's rotation would slow as tidal forces gradually lock Earth into synchronous rotation with the orbital period. One hemisphere would permanently face the black hole while the other faces away. This would create extreme temperature differences between day and night sides. Geological upheaval would reshape continents and create new mountain ranges as Earth's interior gets kneaded by gravitational stress. This slow death march would be infinitely more terrifying than instant destruction, because humanity would have centuries to understand exactly what's happening while being completely powerless to prevent it. Every generation would inherit slightly worse conditions. We'd have enough time to try every possible solution and watch them all fail. We'd have enough time to study our fate in precise detail and understand exactly how our destruction would unfold. But long before tidal forces became significant, humanity would face a much more immediate and obvious crisis that would make orbital mechanics seem like a distant concern. The darkness apocalypse. The complete collapse of Earth's energy system begins the moment our sun disappears. This isn't about needing more flashlights and candles. This is the permanent shutdown of every process that keeps our planet alive. Everything depends on that constant stream of solar radiation, and now it's gone forever. Photosynthesis stops within days. Plants can't convert light energy into chemical energy anymore because there's no light to convert. This isn't just bad news for your garden. Nearly every ecosystem on Earth depends on plants as primary producers. They form the foundation of almost every food chain on the planet. When photosynthesis halts, it triggers an ecological collapse that cascades through every level of life. The smallest microbes lose their energy source first, then insects, then small animals, then larger predators. The entire biological pyramid crumbles from the bottom up. Your local grocery store runs out of fresh produce within a week. Farmers watch their crops wither and die as stored energy in plant tissues gets used up. Livestock starve as grass stops growing and grain supplies dwindle. The agricultural system that feeds billions of people simply ceases to function. Governments start rationing food, but there's no way to grow more. The global food supply becomes whatever was already harvested and stored before the transformation. Earth's surface starts radiating heat into space with no solar input to replace it. The planet becomes a giant radiator, bleeding thermal energy into the cosmic void. Different regions cool at different rates depending on their thermal mass and geographic features. Oceans hold heat longer than land masses. Desert areas lose temperature faster than forests. Mountain peaks freeze before valleys. The planet develops complex temperature gradients that create chaotic weather patterns as hot and cold air masses collide in unpredictable ways. The temperature drop happens fast. Within the first month, average global temperatures plummet by dozens of degrees. Tropical regions that never see snow suddenly experience blizzards. Temperate zones become Arctic wastelands. The polar ice caps expand rapidly as more and more of Earth's surface drops below freezing. Weather systems become completely erratic as the normal patterns driven by solar heating disappear. Water vapor in the atmosphere starts turning into snow within weeks. This isn't regular snowfall that melts when spring comes. This is atmospheric water permanently leaving the gas phase and falling to the ground as ice crystals. The air gets drier as humidity levels crash. Clouds disappear as water vapor condenses out of the atmosphere. The sky becomes crystal clear, but that just makes the stars look brighter against the endless darkness. Different atmospheric gases freeze at different temperatures, creating layers of toxic condensation. Nitrogen stays gaseous the longest, but carbon dioxide starts freezing out when temperatures hit -109 degrees Fahrenheit. This creates solid dry ice that accumulates on the ground like snow. Oxygen freezes at -361 degrees Fahrenheit, so it stays gaseous longer, but as temperatures continue dropping, Even oxygen starts condensing into liquid droplets that pool in low areas. The atmosphere literally starts falling out of the sky. What used to be breathable air becomes a thin mixture of whatever gases haven't frozen yet. Breathing becomes difficult not just because of the cold, but because the air pressure drops as atmospheric mass gets trapped in solid form on the surface. High-altitude areas lose breathable atmosphere first, forcing populations to migrate towards sea level where slightly more air remains gaseous. Humans desperately try to survive using geothermal energy and nuclear power. Geothermal plants tap into Earth's internal heat, which continues radiating from the planet's core, regardless of what happens to the sun. Nuclear power plants keep running as long as their fuel rods hold out, and their cooling systems don't freeze. These become humanity's lifelines, powering emergency heating systems and indoor agriculture facilities that use artificial light to grow food. Underground cities become the only habitable places on Earth. Construction crews work around the clock to dig deeper into the ground where geothermal heat keeps temperatures above freezing. Mining operations expand existing tunnels into vast subterranean complexes. Subway systems get converted into residential areas. Basements become valuable real estate as people seek any shelter from the surface cold. But even the most advanced underground facilities eventually succumb to the cold. Geothermal energy sources are limited and localized. Nuclear fuel runs out after a few years without resupply. The infrastructure needed to maintain these systems requires surface operations that become impossible as temperatures continue dropping. Ventilation systems freeze. Power lines break under the weight of accumulated atmospheric ice. Equipment fails as lubricants and coolants reach their freezing points. The oceans freeze from the surface down, creating ice tombs for marine life. Fish and whales get trapped under thickening layers of ice as their liquid habitat transforms into solid crystal. The freezing process starts at the poles and works toward the equator, but eventually even tropical seas become solid ice. Marine ecosystems collapse as the base of oceanic food webs gets cut off from sunlight and thermal energy. This frozen wasteland phase represents just the beginning of Earth's transformation into something completely unrecognizable. The planet we knew gets buried under layers of atmospheric ice, frozen oceans, and the accumulated debris of a dead ecosystem. Cities disappear under drifts of solid carbon dioxide and water ice. Forests become graveyards of frozen trees. Rivers turn into solid channels of ice that never flow again. Earth starts looking more like Pluto than the blue marble we remember. The surface becomes a uniform white expanse broken only by the geometric patterns of frozen cities and the random shapes of ice formations. The planet's albedo changes dramatically as the dark surfaces that used to absorb heat get covered by reflective ice. If the sun somehow returned, Earth would reflect most of the incoming energy back into space instead of warming up. But this apocalyptic freezing would be interrupted by something far more disturbing. As Earth's orbit gradually decays over thousands of years, our planet would eventually drift close enough to the black hole for much stranger effects to manifest. Spaghettification's true horror. The tidal forces that create spaghettification represent physics at its most brutal and incomprehensible. Everyone knows the term. You picture an astronaut getting stretched like taffy as they fall into a black hole. Simple stretching, right? Wrong. The 2025 calculations show this process is way more complex and horrifying than anyone imagined. It's not just about getting longer. It's about your body experiencing forces that tear you apart in ways that make no physical sense. Tidal forces don't affect everyone equally. Your feet experience stronger gravity than your head because they're closer to the black hole. This sounds straightforward until you realize what it actually means for a human body. The gravitational difference between your head and feet creates internal stresses that your skeleton and muscles never evolved to handle. Your circulatory system gets confused as blood pressure changes dramatically between different parts of your body. Your nervous system starts misfiring as the electrical signals have to travel through tissues experiencing different gravitational environments. The differential forces hit Earth's oceans first, creating tidal patterns that make no sense. High tide and low tide lose all meaning when gravitational forces change depending on your position relative to the black hole, rather than following predictable lunar cycles. Coastal areas experience water levels that rise and fall randomly throughout the day. Some beaches get permanent flooding while others dry up completely. Ocean currents change direction without warning, as water gets pulled toward whichever part of Earth faces the black hole most directly. Surfers would find waves appearing in the middle of previously calm seas, as gravitational forces create pressure differentials in the water. Shipping becomes impossible, as captains can't predict where the water level will be from hour to hour. Ports flood at random intervals. Maritime navigation systems fail because they depend on consistent sea levels and predictable tidal schedules that no longer exist. Mountains start stretching and deforming before anyone realizes what's happening. The Himalayas begin growing taller as rock gets pulled upward by differential gravitational forces. The peaks experience less gravity than the base, so the entire mountain range slowly elongates like geological silly putty. Valleys get deeper as material flows away from areas experiencing maximum tidal stress. Earthquake activity increases dramatically as tectonic plates adjust to forces pulling in directions they never experienced before. Buildings develop structural problems that engineers can't explain. Skyscrapers start leaning as their foundations experience different gravitational forces than their upper floors. Bridges sag in the middle as the support towers and anchor points get pulled in opposite directions. The International Space Station becomes unstable as different sections of the structure experience varying gravitational effects depending on their orientation relative to the black hole. The human body experiences spaghettification as a gradual increase in weight at extremities. Your feet feel heavier because they're being pulled harder toward the black hole. Your hands feel heavier when you raise them above your head because they're fighting against stronger gravitational forces. Walking becomes exhausting as each step requires lifting feet that seem to weigh more than they should. Reaching for objects on high shelves becomes nearly impossible as your arms feel like they're made of lead. The horrifying realization hits when you understand that the stretching isn't uniform. Some parts of your body elongate while others compress. Your torso gets squeezed horizontally as gravitational forces press in from the sides. Your spine stretches vertically as your head gets pulled away from your feet. Your ribcage changes shape as the bones adapt to forces pulling in directions that human anatomy never anticipated. Internal organs shift position as they respond to gravitational gradients that change throughout your body. Blood circulation becomes chaotic as your cardiovascular system tries to pump fluid through vessels experiencing different gravitational environments. Blood pools in your feet because it's harder to pump against the stronger gravitational forces there. Your brain gets less oxygen as blood struggles to flow upward against the increasing gravitational gradient. You experience dizziness and confusion as your circulatory system fails to adapt to the impossible physical conditions. The process accelerates exponentially as Earth approaches the event horizon. What started as minor joint pain becomes unbearable stretching forces that increase by orders of magnitude with each passing day. The gravitational gradient becomes so steep that the difference in force between your head and feet exceeds what human tissue can withstand. Bones start fracturing under the differential stress. Muscles tear as they're pulled in directions they can't accommodate. Your nervous system begins shutting down as the physical structure of your brain gets distorted by tidal forces. Neurons lose their ability to communicate effectively as the tissue they're embedded in stretches and compresses. Memory formation becomes impossible. Speech becomes slurred as the muscles controlling your tongue and vocal cords experience conflicting gravitational pulls. Motor control fails as your brain loses its ability to coordinate movements in a body that's changing shape continuously. The most terrifying aspect is that consciousness might persist through the initial stages. You remain aware while your molecular structure gets torn apart. You can feel every bond breaking as the gravitational forces exceed the electromagnetic forces holding your atoms together. You experience the dissolution of your physical existence at a cellular level. Your awareness doesn't fade gently like falling asleep. Instead, you remain conscious while your body disintegrates around your still functioning mind. The final stages happen faster than human perception can process. Within seconds, the exponential acceleration of tidal forces tears apart every molecule in your body. Carbon bonds snap, hydrogen atoms separate from their molecular partners. The complex chemistry that creates consciousness gets reduced to individual atomic components scattered across space. Your last moment of awareness occurs as the electrical activity in your brain gets disrupted by forces that make your neurons physically impossible to maintain. What remains isn't even recognizable as having once been human. The atoms that used to form your body get stretched into thin streams of matter falling toward the event horizon. But these scattered particles don't simply vanish into nothingness. The accretion disk inferno. Instead, they join something far more spectacular and deadly. What happens to all the matter that gets pulled toward a black hole? It doesn't just disappear into the void like you might think. Instead, it forms something called an accretion disk. Picture a spinning death spiral of superheated matter that makes Earth's most violent storms look like gentle breezes. This cosmic blender operates on a scale that defies human comprehension, and any material from our planet would inevitably join this infernal machine of destruction. The accretion disk forms because matter can't fall straight into a black hole. Everything has some sideways motion, some angular momentum that sends it into orbit around the gravitational monster. But these aren't stable orbits like planets around a star. The material spirals inward, getting faster and hotter with each revolution. Think of water going down a drain, except the water is made of plasma hot enough to vaporize diamonds instantly. Any debris from Earth would join this cosmic carousel of annihilation. The chunks of our planet that survived spaghettification would get mixed in with dust, gas, and debris from countless other objects that fell victim to the black hole over millions of years. Your neighborhood, your house, your car, everything you've ever known would become part of this swirling maelstrom of superheated particles. The atoms that once formed mountains and oceans would dance together in a ballet of destruction that stretches across millions of miles. Friction within the accretion disk heats matter to temperatures that make the sun's core look cool. We're talking about millions of degrees, hot enough to strip electrons from atomic nuclei and create plasma that glows with the intensity of 1,000 stars. This isn't the gentle warmth of a campfire, or even the searing heat of molten lava. This is temperature so extreme that the very concept of solid matter becomes meaningless. Everything becomes a soup of charged particles, moving at incredible speeds. The heat generates X-ray radiation so intense it would sterilize anything within light years of the black hole. These aren't medical X-rays that help doctors see your bones. These are high-energy photons that tear through DNA, destroy cellular structures, and cook organic matter at the molecular level. The radiation creates a dead zone around the black hole where no life could possibly survive. Any planet, moon, or asteroid within this sphere of death gets bathed in lethal radiation that makes nuclear fallout look harmless. The disk's magnetic fields accelerate particles to near light speed, creating cosmic rays that make interstellar space look like a peaceful meadow. These charged particles get whipped around by magnetic field lines that twist and tangle like invisible tornadoes. Protons and electrons reach velocities that approach the cosmic speed limit, carrying energy levels that can punch through solid rock. When these particles finally escape the magnetic prison of the accretion disk, they spray out into space as deadly radiation beams. The most terrifying aspect is how these radiation jets can randomly point toward any part of the surrounding galaxy. The black hole's rotation, and the chaotic magnetic fields in the accretion disk create beams of destruction that sweep through space like lighthouse searchlights from hell. If one of these jets happened to point toward Earth during our final approach, we'd get hit with a concentrated dose of radiation that would strip away our atmosphere and sterilize the surface in seconds. Observations from 2025 show that accretion disks can persist for millions of years without losing their deadly intensity. Unlike stars that eventually burn out or planets that cool down over geological time, these cosmic death machines keep operating at full power for longer than complex life has existed on Earth. They create permanent hazard zones that make entire regions of space uninhabitable for any conceivable form of life. The visual spectacle would be breathtakingly beautiful and absolutely lethal. The accretion disk glows with colors that don't exist anywhere else in the universe. Blue-white hot plasma swirls in perfect spirals that stretch across distances larger than our entire solar system. The light output exceeds that of entire galaxies, creating a beacon visible from billions of light years away. Earth's final moments would be illuminated by the most spectacular light show in the cosmos, a funeral pyre bright enough to outshine 1 trillion stars. The disk generates more energy per second than our sun will produce in its entire 10 billion-year lifetime. This power comes from the gravitational potential energy of matter falling toward the event horizon. As material spirals inward, it converts its mass into pure energy through processes that make nuclear fusion look inefficient. The accretion disk becomes a cosmic power plant that transforms matter into radiation with an efficiency that approaches the theoretical maximum allowed by physics. Joining the accretion disk means Earth's atoms would be recycled into this cosmic death machine for eternity. The carbon that once formed living creatures, the oxygen that filled our atmosphere, the silicon that built our mountains, all of it would become fuel for the disk's eternal inferno. Our planet's elements would spiral around the black hole for millions of years, getting heated and accelerated and mixed with debris from countless other worlds that met the same fate. The disk preserves no memory of what the matter used to be before it joined the spiral of destruction. A hydrogen atom that once participated in photosynthesis in an Earth forest becomes indistinguishable from hydrogen that came from a distant star or alien planet. The accretion disk is the ultimate recycling center, breaking down the organized structures of planets and stars into their fundamental components and mixing them into a homogeneous soup of superheated plasma. But even this eternal dance of destruction might not represent the final chapter in our planet's cosmic story. The black hole itself holds secrets that challenge everything we think we know about permanence and oblivion. Hawking radiation paradox. Stephen Hawking discovered something that breaks your brain about these cosmic monsters. Black holes actually emit radiation and slowly evaporate. You'd think something that sucks in light would be permanently dark, but quantum mechanics says otherwise. Virtual particle pairs pop into existence near the event horizon. One falls in while the other escapes as radiation. The black hole loses mass through this process and eventually disappears completely. Even the black hole that replaced our sun would start radiating away its mass particle by particle until nothing remains. This sounds like good news until you realize the timeline involved. For a solar mass black hole, the evaporation process takes roughly 10 to the 67th power years to complete. That's a 1 followed by 67 zeros. The numbers are so large they don't have names. The Hawking radiation from our replacement black hole creates a temperature paradox that makes the situation even stranger. The radiation's temperature is inversely proportional to the black hole's mass. Smaller black holes emit hot radiation, while larger ones emit cold radiation. A solar mass black hole radiates at temperatures measured in billionths of a degree above absolute zero. This creates an impossible situation. The cosmic microwave background has a temperature of about 2.7 Kelvin above absolute zero. The Hawking radiation from our black hole comes out much colder than the universe's background radiation. The black hole is so cold compared to its surroundings that it actually absorbs more energy from the universe's leftover heat from the Big Bang than it emits through Hawking radiation. Instead of shrinking, the black hole continues growing by feeding on the universe's background thermal energy. Every photon of cosmic microwave background radiation that crosses the event horizon adds to the black hole's mass. The rate of growth from absorbing background radiation exceeds the rate of mass loss from Hawking radiation by enormous factors. The black hole becomes a cosmic vacuum cleaner that sucks up the universe's thermal energy while contributing virtually nothing back. This means our replacement black hole is essentially immortal in the current universe. It won't start shrinking until the cosmic microwave background cools down enough that its temperature drops below the temperature of the black hole's Hawking radiation. The universe would need to expand and cool for trillions upon trillions of years before this equilibrium point gets reached. Long after every star has burned out and died, long after galaxies have drifted apart beyond the cosmic horizon, our black hole will still be growing slowly by absorbing the fading remnants of creation itself. The 2025 quantum mechanics research has refined our understanding of what happens to information that falls into black holes. This creates the information paradox, one of the biggest unsolved problems in physics. Quantum mechanics says information can never be destroyed, but general relativity suggests that anything falling into a black hole gets permanently erased from the universe when the black hole eventually evaporates through Hawking radiation. Recent theoretical work suggests that information doesn't actually get destroyed when it crosses the event horizon. Instead, it gets encoded in the subtle quantum properties of the black hole's structure. The information becomes part of the black hole's quantum state, stored in correlations between the Hawking radiation particles and the black hole's interior. This encoding process is so complex that the information appears lost from any practical perspective, but it remains preserved in the fundamental quantum structure of reality. Any information about Earth would be encoded on the black hole's event horizon forever according to these theories. Every atom that made up our planet, every chemical reaction that ever occurred in a living cell, every thought that ever passed through a human brain, all of it would become part of the black hole's quantum information content. The data wouldn't be stored in any recognizable form. You couldn't read it like a book or decode it like a computer file. But the information would persist as quantum correlations that define the black hole's fundamental properties. The holographic principle suggests that all the information contained within a volume of space can be encoded on the boundary of that volume. For black holes, this means that everything that ever falls past the event horizon gets encoded as information on the surface of the event horizon itself. Earth's entire history would be written in the quantum fluctuations of the black hole's boundary, preserved in a form that transcends normal matter and energy. This creates a twisted form of immortality that defies human comprehension. Earth would cease to exist as a physical object made of atoms and molecules, but every piece of information that defined our planet would become part of the black hole's eternal quantum structure. The carbon atoms that formed DNA, the electromagnetic patterns that stored memories in human brains, the precise positions and velocities of every particle that ever existed on Earth, all of it would be preserved in quantum correlations that outlast the universe itself. The black hole becomes a cosmic library that stores the complete information content of everything it has ever consumed. Unlike regular libraries, where information gets organized and indexed for easy retrieval, the black hole's information storage system scrambles everything beyond recognition. The data remains preserved according to the fundamental laws of quantum mechanics, but it gets encoded in such a complex way that extracting specific information becomes practically impossible. But this quantum preservation of information represents only one way that Earth's destruction would leave permanent traces in the universe. The process of our planet's final spiral toward oblivion would generate something far more detectable and immediate. Gravitational wave tsunami. Gravitational waves would ripple through spacetime itself, announcing Earth's doom to anyone with the right equipment to listen. These invisible forces constantly wash over you as black holes merge and neutron stars collide across the universe. You can't see them, hear them, or feel them directly, but when our planet begins its final spiral into the black hole, these ripples would become Earth's cosmic death certificate. The 2025 Advanced LIGO detectors can measure these spacetime ripples with precision that seems impossible. They detect changes in distance smaller than 1/10,000, the width of a proton, by using laser beams that travel back and forth between mirrors positioned miles apart. When a gravitational wave passes through, it literally stretches space in one direction while compressing it in the perpendicular direction. The laser light takes slightly longer to complete its journey in the stretched direction, creating interference patterns that reveal the wave's properties. These detectors have become so sensitive they can pick up gravitational waves from black hole mergers happening billions of light years away. The waves arrive at Earth as faint whispers of cosmic violence, carrying information about the masses and spins of objects that collided when the universe was much younger. Each detection tells a story of destruction written in the language of warped spacetime, decoded by scientists who translate the data into audio frequencies that sound like chirping birds or whooping calls. Earth's spiral into the black hole would create an accelerating gravitational wave signal, unlike anything our detectors have ever recorded. The waves would start weak and slow as our planet begins its death dance millions of miles from the event horizon. Our orbital motion around the black hole would generate ripples in spacetime that carry away energy, causing Earth's orbit to decay faster. This creates a feedback loop where gravitational wave emission speeds up the orbital decay, which creates stronger gravitational waves, which accelerates the decay even more. The signal would sound like a cosmic heartbeat growing faster and stronger as Earth approaches its fate. Early in the process, the waves would arrive at a leisurely pace, maybe one pulse every few seconds as Earth completes each orbit around the black hole. But gravitational wave frequency increases as orbiting objects get closer together and move faster. The heartbeat would accelerate exponentially, going from seconds between pulses to milliseconds to microseconds, as Earth spirals inward at increasing speed. These waves would literally stretch and compress space itself throughout the solar system and beyond. As each gravitational wave passes through Earth, the distance between atoms in your body would oscillate by amounts smaller than the nucleus of an atom. Your height would change by a few billionths of a meter as space stretches and compresses around you. The planet itself would grow and shrink rhythmically as gravitational waves wash over it, though the changes would be far too small for human senses to detect. Sensitive equipment around the world would register this cosmic heartbeat growing faster and stronger with each passing day. GPS satellites would detect tiny timing variations as their atomic clocks experience different amounts of spacetime stretching. Particle accelerators would need constant recalibration as the distances between their components fluctuate with each gravitational wave pulse. Even the most precise scientific instruments would show mysterious oscillations that perfectly match the frequency of Earth's orbital decay. The waves would interfere with each other in complex patterns as they bounce around the solar system and reflect off massive objects like Jupiter and Saturn. Some regions of space would experience amplified stretching, while others get compressed more strongly. The interference creates nodes and antinodes in the gravitational wave field, producing a three-dimensional pattern of spacetime distortion that changes constantly as Earth's orbital frequency increases. As Earth approaches the point of no return, the gravitational waves would reach intensities that dwarf anything previously detected. The final few seconds before our planet crosses the event horizon would produce waves carrying more energy than our sun radiates in millions of years. Space itself would ring like a bell struck by a cosmic hammer, sending shockwaves of curved spacetime racing outward at light speed in all directions. The last moments would generate gravitational waves so intense they could be detected across the observable universe by any civilization with technology similar to our own. The signal would be unmistakable, a characteristic pattern that could only come from a planet-sized object falling into a black hole. The waves would carry detailed information about Earth's mass, the black hole's properties, and the exact dynamics of our planet's final approach to the event horizon. This gravitational scream would be Earth's final message to the cosmos, a death song written in the fundamental language of space-time geometry. The waves would propagate outward at the speed of light, reaching nearby star systems within years and distant galaxies within millions of years. Any alien civilization with gravitational wave detectors would eventually receive this signal and decode its meaning with perfect clarity. The Laser Interferometer Space Antenna mission launching in the next decade will make detecting such events even easier. LISA consists of 3 spacecraft that shoot laser beams back and forth over millions of miles to measure their separations with incredible precision. This space-based detector will be sensitive to gravitational waves from merging black holes with masses up to hundreds of millions of suns, making it perfect for detecting the kind of signal Earth's destruction would produce. Civilizations billions of light years away would eventually detect Earth's death song and know exactly when and how we died. The gravitational wave signal contains enough information to reconstruct the entire event, from the initial orbital decay through the final plunge into the black hole. The waves would continue propagating through the universe long after Earth ceased to exist, carrying our planet's obituary to regions of space so distant that light from our destruction will never reach them. But these gravitational waves represent only one aspect of the cosmic distortion that would accompany Earth's final approach. The black hole's immense gravity would warp something even more fundamental than space itself. Time dilation nightmare. Time itself becomes Earth's worst enemy as our planet approaches the black hole. Einstein's relativity reveals that time runs slower in stronger gravitational fields, and the mind-bending consequences of this effect would tear apart everything humans understand about coordinated existence. You think the orbital decay and freezing temperatures are bad, but the breakdown of time synchronization across Earth would make survival impossible even if we solved every other problem. Different parts of Earth would experience time at completely different rates as we spiral toward the black hole. The side of our planet facing the gravitational monster would have time moving significantly slower than the far side. This isn't some abstract physics concept that only matters to scientists with atomic clocks. This is a practical nightmare that would make basic human coordination impossible. People living in New York would age at a different rate than people living in Tokyo, depending on which side of Earth faces the black hole at any given moment. The horror starts small but grows exponentially worse. Initially, the time difference between Earth's near side and far side might only amount to microseconds per day. Precision instruments would detect the discrepancy, but humans wouldn't notice anything unusual in their daily lives. Clocks in different cities would drift apart by tiny amounts that seem insignificant. Computer networks would experience synchronization errors that tech support would dismiss as normal system glitches. As Earth approaches closer to the black hole, the time differential accelerates dramatically. What started as microseconds becomes milliseconds, then full seconds, then minutes of difference between regions separated by Earth's diameter. People on the black hole side of the planet would experience Monday morning, while people on the far side are still dealing with Sunday night. Conference calls between time zones would become literally impossible because participants would be living in different temporal realities. The aging process creates the most disturbing psychological effects. Families separated by continental distances would age at visibly different rates. A husband working in Europe might return home to find his wife in America has aged several extra days during his business trip. Children would grow up watching their grandparents in distant cities aging faster or slower, depending on the gravitational gradient. The concept of shared human experience would crumble as people realize their biological clocks are running at different speeds. Emergency services would collapse as coordination becomes impossible between regions experiencing different time flows. Fire departments couldn't dispatch trucks because their clocks would be out of sync with emergency call centers. Hospitals couldn't coordinate with ambulance services when each vehicle experiences time differently depending on its location. Air traffic control would shut down as pilots and controllers operate with clocks that disagree about basic timing. The infrastructure that depends on precise synchronization would fail catastrophically. Global communications networks would fragment as data packets arrive at destinations that have moved forward or backward in time relative to their origin points. Internet connections would time out as servers on different sides of Earth experience different temporal flows. Financial markets would crash as trading algorithms fail to synchronize buy and sell orders across exchanges operating at different temporal rates. The global economy would collapse as monetary transactions require agreement about when events occur. The psychological impact on humanity would be devastating as people watch their loved ones aging at different rates depending on where they live. Parents would see their children growing up faster or slower than normal. Couples separated by distance would experience relationship problems as one partner ages weeks or months ahead of the other. The shared human experience of growing old together would fragment into isolated pockets of people experiencing time at their own local rate. As Earth approaches the event horizon, the time differential would accelerate to extreme levels. The black hole-facing side of Earth would experience hours passing, while the far side experiences days. People could walk from one hemisphere to another and literally travel through time relative to their starting point. The planet would become divided into temporal zones, where human civilization fragments into isolated communities that can't maintain contact with each other. From an outside observer's perspective, Earth would appear to slow down and freeze at the event horizon. Any alien civilization watching our planet's destruction would see Earth's final approach stretched across millions of years, as time dilation effects become infinite near the point of no return. Radio signals from Earth would become increasingly redshifted and slow as our planet appears to coast toward the event horizon at decreasing speed. The paradox creates a nightmare scenario where Earth's destruction appears to take forever from outside, but happens instantly for those experiencing it. People living through the final moments would experience normal time flow as their planet gets torn apart by tidal forces. But distant observers would see Earth frozen in place at the event horizon, its destruction stretched across geological timescales. Clock synchronization would become completely impossible in Earth's final stages, as different regions experience time flow rates that differ by orders of magnitude. The planet would develop temporal zones where walking a few miles could transport you through days or weeks of relative time. Communication between these zones would cease as radio waves take different amounts of time to travel through regions experiencing different temporal flows. The final revelation hits when you realize that Earth's destruction would be stretched across eternity for the rest of the universe to witness. Our planet's death throes would be visible to alien observers for millions of years, as time dilation freezes our final moments at the event horizon. But this assumes that our understanding of what happens at the event horizon is actually correct. Recent theoretical physics suggests something far stranger might be waiting there. The information firewall. The firewall hypothesis suggests that Earth's encounter with the black hole might violate every assumption about how physics works at the event horizon. Instead of smoothly crossing an invisible boundary like walking through a doorway, our planet could slam into a wall of high-energy particles that exists right at the event horizon. This firewall would be completely invisible until you actually reach it. But hitting it would be like flying into a nuclear explosion that stretches across millions of miles. The problem comes from trying to solve the black hole information paradox that has been driving physicists crazy for decades. Quantum mechanics says information cannot be destroyed under any circumstances. Every particle that has ever existed carries information about its properties, position, momentum, and quantum state. When that particle falls into a black hole, the information should be preserved somehow. But general relativity says anything crossing the event horizon gets permanently trapped inside where it can never escape or communicate with the outside universe. Both theories can't be right simultaneously, so physicists have been scrambling to find solutions. The firewall hypothesis offers one potential answer, but creates a nightmare scenario for anything approaching the black hole. If information must be preserved according to quantum mechanics, then the event horizon becomes a region where quantum entanglement breaks down violently. The smooth spacetime that general relativity predicts gets replaced by a barrier of particles moving at near-light speed, with temperatures that exceed the core of stars. Earth's approach to this firewall would appear completely normal until the final moments. Our planet would spiral inward following the orbital decay patterns predicted by general relativity. The gravitational forces would behave exactly as Einstein's equations suggest. The time dilation effects would match theoretical predictions. Everything would seem to follow the standard model of black hole interactions right up until Earth reaches the event horizon boundary. Then reality breaks. The firewall theory suggests that quantum field fluctuations near the event horizon become so intense they create particle pairs with energies that dwarf anything seen in the universe. These aren't the gentle virtual particles that create Hawking radiation. These are real particles accelerated to relativistic speeds by the breakdown of spacetime geometry itself. The firewall forms when quantum entanglement between the black hole interior and exterior reaches a critical threshold that makes smooth passage impossible. Earth would hit this wall of destruction and get instantly vaporized. The firewall would convert our planet's matter into elementary particles and radiation within nanoseconds. The process wouldn't be gradual like spaghettification. There would be no time for Earth to stretch or compress or experience tidal forces. The entire planet would simply cease to exist as organized matter and become part of the high-energy particle spray that forms the firewall itself. This quantum mechanical horror scrambles Earth's information and redistributes it across the black hole's surface in ways that make no intuitive sense. Every atom that made up our planet, every chemical bond that created organic molecules, every electron that participated in neural activity inside human brains, all of it gets converted into quantum information encoded on the event horizon. The process preserves the information content of Earth while completely destroying its physical structure. The firewall represents a fundamental breakdown in our understanding of physics that goes beyond just black holes. If the event horizon creates a region where smooth spacetime becomes impossible, then our entire framework for understanding gravity needs revision. General relativity assumes that spacetime is continuous and differentiable everywhere except at singularities. The firewall hypothesis suggests that quantum effects can create discontinuities in spacetime that make Einstein's field equations meaningless. The possibility that reality itself becomes undefined at the event horizon challenges everything scientists thought they knew about the relationship between quantum mechanics and gravity. The firewall exists in a regime where neither theory provides clear predictions. Quantum field theory in curved spacetime breaks down because the background geometry becomes too distorted. General relativity fails because quantum effects dominate the physics. We enter a realm where the laws of physics as currently understood simply don't apply. Earth's atoms would be converted into pure information and scattered across the black hole's surface, according to the holographic principle. This concept suggests that all the information contained within a volume of space can be encoded on the boundary of that volume. For black holes, everything that falls past the event horizon gets encoded as quantum information on the two-dimensional surface of the event horizon itself. Earth's three-dimensional structure would be compressed into a holographic representation that preserves all the information while occupying no volume. The conversion process challenges our understanding of what matter and energy actually represent at the fundamental level. If atoms can be transformed into pure information without losing any essential properties, then matter might be nothing more than organized patterns of information that create the illusion of solid objects. The firewall would reveal that everything we consider real and substantial is actually just information arranged in specific configurations that our senses interpret as physical reality. The encoding mechanism operates through quantum entanglement networks that connect every part of the event horizon to every other part. Earth's information gets distributed across the entire surface rather than remaining localized to one region. A carbon atom from your body might end up encoded next to information from a dinosaur fossil and a piece of the Pacific Ocean. The scrambling process mixes all of Earth's information together, while preserving the total amount according to quantum mechanical conservation laws. The implications extend far beyond just Earth's destruction. If black holes contain firewalls that break the known laws of physics, then the universe operates according to rules that scientists haven't discovered yet. The merger of quantum mechanics and general relativity might require completely new mathematical frameworks that go beyond current theoretical physics. Black holes become laboratories for studying physics that doesn't exist anywhere else in the universe. Whether Earth gets smoothly absorbed or hits the firewall and gets instantly vaporized, the end result leads to the same fundamental question about what happens to all that matter and energy. The ultimate cosmic recycling. The atoms that comprise our planet don't simply disappear into oblivion. The universe operates according to conservation laws that make true destruction impossible. Everything gets recycled through processes that span timescales longer than human civilization has existed. The carbon in your body, the oxygen you breathe, the iron in your blood, all of it continues existing, but transformed into something completely different. This cosmic recycling program has been running for nearly 14 billion years. Stars explode and scatter their elements across space. Planets form from the debris of previous generations of worlds. Black holes consume matter and energy, then slowly release it back through Hawking radiation over unimaginable timescales. The same carbon atoms that form diamonds in Earth's crust might have once been part of ancient stars that died billions of years before our solar system formed. The iron in your blood was forged in the nuclear furnace of a massive star that exploded long before Earth existed. Earth's atoms would be broken down to their most fundamental components during the black hole encounter. The intense gravitational fields don't just crush matter or stretch it apart. They dismantle the very structure of atoms themselves. Electrons get stripped away from nuclei. Protons and neutrons separate into their constituent quarks. The electromagnetic forces that hold molecules together become meaningless compared to the gravitational forces tearing everything apart at the subatomic level. The gravitational fields convert matter into pure energy through processes that scientists are still trying to understand. Mass and energy are interchangeable according to Einstein's famous equation, but the mechanisms operating near black holes go beyond anything we can reproduce in laboratories. The extreme spacetime curvature creates conditions where the normal rules of physics break down. Matter doesn't just get crushed or heated. It gets transformed into forms of energy that might not exist anywhere else in the universe. This energy eventually gets radiated away as the black hole slowly evaporates over cosmic time. Hawking radiation represents the black hole's way of returning energy to the universe, but the process takes longer than the current age of the universe for solar mass black holes. Every photon of Hawking radiation carries away a tiny amount of the black hole's mass. Over trillions upon trillions of years, the entire black hole would evaporate completely, returning all the mass and energy it ever consumed back to the cosmos. Earth's carbon, oxygen, hydrogen, and all the other elements would be returned to the universe as elementary particles. The carbon atoms that once formed trees in Amazon rainforests would become part of the Hawking radiation stream. The oxygen that filled our atmosphere would get broken down and rebuilt as fundamental particles that carry no memory of their previous existence as breathable air. The complex chemistry that created life on Earth would be reduced to its most basic components and scattered across space. These particles could eventually form new stars and planets in the far future. The matter that once comprised Earth would drift through space for millions or billions of years until gravity pulls it together into new cosmic structures. Future star formation would incorporate Earth's recycled atoms into fresh stellar cores, where nuclear fusion would forge them into new elements. Planetary systems would coalesce from the debris, creating worlds that contain traces of Earth's matter without any knowledge of their origin. The 2025 understanding of quantum mechanics suggests that information about Earth might be preserved in quantum fluctuations even after our planet's physical destruction. The information paradox remains one of physics' biggest unsolved problems, but recent theoretical work indicates that quantum information gets encoded in ways that transcend normal matter and energy. Earth's complex history might persist as patterns in the quantum foam that underlies all of reality, preserved in correlations that survive even the death of the black hole itself. This creates a poetic irony where Earth's destruction contributes to the birth of future worlds. The same atoms that formed continents and oceans on our planet would become building blocks for alien worlds orbiting distant stars. The phosphorus that once carried genetic information in DNA might someday become part of different life forms that evolve under foreign suns. The silicon that formed Earth's rocky crust could end up in the computer circuits of civilization that arise billions of years in the future. Stellar nucleosynthesis would incorporate Earth's recycled matter into the cosmic cycle of element creation. When the particles that once formed our planet get drawn into new stars, they would participate in the nuclear reactions that forge heavier elements. The hydrogen that once filled Earth's oceans might eventually become carbon in a distant star's core. The carbon from our biosphere might get fused into oxygen or neon in stellar furnaces that won't ignite for millions of years. Future planetary systems would inherit Earth's chemical legacy without knowing it. Rocky planets would form from materials that include atoms from our world mixed with debris from countless other dead planets. Atmospheres would develop using gases that once sustained life on Earth, but now carry no trace of their biological history. The recycling process would be so complete that no chemical signature would remain to indicate which atoms came from which source. Every atom in your body has already been recycled countless times through stellar cores, planetary surfaces, and biological systems. The matter that forms Earth today was once part of the primordial gas clouds that collapsed to form the first generation of stars. Those stars lived and died, and scattered their processed elements into space where they became part of new stars and planets. Earth represents just one temporary arrangement of atoms that will eventually be rearranged into different configurations. The universe operates like a cosmic recycling center that never loses any material, but constantly transforms it into new forms. Black holes serve as processing stations that break down complex structures and return their components to the cosmic inventory. Earth's encounter with a black hole would be our planet's contribution to this endless cycle of cosmic renewal that has been operating since the beginning of time and will continue long after the last star burns out. These gravitational monsters embody something far more complex than simple destruction. Our sun's replacement with a black hole would create the most extreme scenario physics allows. These objects represent the universe's ultimate contradiction. They destroy everything they touch, while simultaneously serving as cosmic creation engines that shape galaxies and forge the elements needed for life. Black holes with masses ranging from millions to billions of times our sun don't just consume matter. They regulate star formation across entire galaxies and determine which worlds get the chance to develop complex chemistry. The James Webb Space Telescope reveals these objects existed when the universe was less than 1 billion years old, some weighing 1,000 times more than they should according to current models. They're not just destroyers. They're architects of cosmic evolution that built the universe we inhabit today. Next time you watch sunrise, remember how perfectly balanced our solar system really is.